everyone. Now we are going to start data science. Data science first internal, part C, that is data pre-processing for feedback analytics. In this question 9, we are going to discuss issues like accuracy, completeness, and consistency in student feedback, faculty feedback, uh, proposed to other dimensions of data quality. So first we have accuracy. In this, we have issue and example. We have given an issue and an example, similar with second completeness, consistency, and two additional dimensions we are having here, that is timeliness and validity or uniqueness. So accuracy issue is students might mark random answers just to complete the survey quickly. Example, a student gives 5 to 5 stars but writes teaching was poor in comments. This is accurate data. Completeness, optional fields left blank. Example, a student rates a subject knowledge but leaves the communication skills blank. Consistency, issues different scales or conflicting formats. Example, one survey uses a scale of 1 to 10, other uses 1 to 5, merging them creates inconsistency. Now we have two additional dimensions. First, timeliness. Is the data current? Feedback given 6 months after the semester ends is useless for intermediate improvement. Validity, uniqueness. Are there duplicate entries? Example, one student submitting the form twice to screw rating. In next question, we are going to discuss approaches such as ignoring tuples, filling manually, constants, mean, median imputation, class specific imputation, etc. So in this first method one, ignore the tuple, uh, which is delete row. So what action we take is delete the student record completely. So its pros are is simple, but cons is loss of valuable data. Only recommended if the data set is huge and missing values are few. And method 2 is fill manually. So what action we take is check hard copies or ask the student. And cons is tedious and impossible for large data sets, which is big data. Next, method 3 is fill with global constant. Action we take is replace missing with unknown or -1. And cons is the algorithm might mistake -1 for a real low score. Now, method 4 is central tendency, which is mean mode median. So, action we take is replace missing rating with the average rating of the class. Pros, preserves the overall mean, and cons, reduces variance, makes data look too normal. Method 5th, class specific imputation, smarter. Action, instead of global average, use the average of student in the same department semester. Pros, more accurate context. Method 6, most probable value prediction. Action we take is use regression or decision tree to predict the missing value based on other answers. And pros is most accurate method. Next question 11th. In this, we are first going to smooth the rating using bean means with bean depth. Three, B suggest ways to detect outliers. C discuss other methods for data smoothing. So we have given the data. Step 1 is partition into beans. That is depth is equals to 3. First divide the sorted data into buckets containing 3 items each. This we have sorted data and we have sorted them data into buckets. Each bucket contains 3 items. So we have bean 1 to bean 9. Second, we calculate the bean means. So in this, we replace all the values in a bean with the average mean of that bean. This is the calculation of mean from bean 1 to bean 9. And here are the means, means of each bean. Now B, we have outlier detection, in which first box plot or IQR method, which is any value will be greater than Q3 plus 1.x IQR, is an outlier. Here 70 is likely an outlier. Z score, calculate dollar Z is equals to uh, curly bracket dollar. If dollar Z is greater than $3, it's an outlier. Third, scatter plot, visual inspection. See other smoothing method, mean medians. Replace values with the median. Mean boundaries, replace values with the closest boundary value. Next question, we have 12th question. In this we are going to explain the data integration for MC and MTech analytics, discussion schema integration, handling redundant data and resolving conflicts in values. What is its context? Merging data from multiple sources. So first we have schema integration and entity identification. So first we have schema integration and entity identification. Second we have handling redundant data, and third we have resolving data value conflicts. So each of these identifications and schemas have problem, example, and solution. You can go through it. Next question 13. In this, we are going to discuss normalization methods, which is A, min and max, Z score, C, Z score using mean, absolute deviation, and D, decimal scaling. So first, mean max normalization rescales data to a fixed range, usually 0 and 1. Formula is our min-max normalization formula is equals to V minus min A upon max A minus min A into mu max minus nu min plus nu min. So formula pros is preserves all the relationships exactly. Cons is outliers can squash the rest of the data into a tiny range. Next, B z-score normalization, which is zero mean, rescales data based on mean and standard deviation, which is sigma. So our z score is equals to uh, v minus nu by sigma, which is standard deviation. Formula pros handles outliers better than min max, useful when actual min max are unknown. Z score using mean absolute deviation, which is MAD, used when standard deviation is too affected by extreme outliers. So V dash is equals to V minus nu by SA, where SA is equals to 1 by N summation V minus nu. So used when standard deviation is too affected by extreme outliers. Next we have D, decimal scaling, moves the decimal point of values to attribute A. Formula is V dash is equals to V by 10J is the smallest integer in which max V dash is less than 1.